Out in the far reaches of our solar system, far beyond Earth and far from the warmth of the sun, you would expect everything to be frozen, silent, and lifeless. But recently, scientists received something surprising. Images captured by one of NASA's advanced space probes revealed a strange and chaotic world. A landscape filled with bizarre formations and violent eruptions, unlike anything we see on Earth. These images came from a small moon orbiting the giant planet Jupiter, a moon called Io. And surprisingly, Io is not a quiet, frozen world at all. In fact, it is the most volcanically active place anywhere in our solar system. Its surface is constantly changing, caught in a dramatic struggle between extreme heat and deep freezing temperatures. Giant volcanic eruptions reshape the landscape over and over again, creating one of the most dynamic environments scientists have ever observed. To understand why Io is so unusual, we first need to look at the system it belongs to. Jupiter is not just the largest planet in the solar system, it is also surrounded by a huge family of moons. Scientists have already identified almost 100 moons orbiting the gas giant, and the number continues to grow as new objects are discovered. Most of these moons are small and irregular, but 4 of them are enormous. These are known as the Galilean moons, first observed more than 400 years ago by the famous astronomer Galileo Galilei using one of the earliest telescopes ever built. Each of these moons is fascinating in its own way. The outermost moon, Callisto, is a heavily cratered world that has remained almost unchanged for billions of years. Next is Ganymede, which holds the record as the largest moon in the solar system, even bigger than the planet Mercury. Then there is Europa, a smooth, icy world that scientists believe hides a vast ocean of liquid water beneath its frozen surface. Because of this hidden ocean, Europa is considered one of the most promising places in the solar system where extraterrestrial life might exist. But the most dramatic and extreme moon of them all lies closest to Jupiter. That moon is Io. Io orbits just about 350,000 kilometers above Jupiter's cloud tops, which is not much farther than the distance between Earth and our own moon. It's roughly similar in size to Earth's moon, although slightly larger and heavier. However, its internal composition is very different. Unlike many outer solar system moons that are made largely of ice, Io is composed mostly of rock and metal. This makes it the densest moon in the entire solar system. In fact, scientists believe Io may contain less water than almost any other known object in our solar system, possibly even less than Mercury itself. But Io's real uniqueness lies on its surface. This moon is covered in volcanoes, hundreds of them. Scientists estimate that around 400 active volcanoes exist on Io at any given time. That makes Io the most volcanically active world we know. This incredible discovery was first made in 1979 when NASA's Voyager 1 spacecraft flew past Jupiter. Even though Voyager's cameras were relatively simple compared to modern technology, they captured something astonishing. Scientists could clearly see massive plumes erupting from Io's surface. At least 9 separate volcanic eruptions were visible in the images. Some of these eruptions were so powerful that they sent material hundreds of kilometers above the moon's surface. But here's the strange part. Outside the volcanic regions, Io is incredibly cold. Surface temperatures in some areas drop to around 130 degrees C. So where does all the heat powering these volcanoes come from? The answer lies in Jupiter's enormous gravitational pull. Io orbits extremely close to the giant planet, which means Jupiter's gravity constantly pulls on the moon. But Jupiter isn't the only force affecting Io. The other large moons, Europa, Ganymede, and Callisto, also exert gravitational forces on Io as they orbit the planet. These competing forces slightly distort Io's orbit, making it oval-shaped instead of perfectly circular. Because of this, Io is sometimes closer to Jupiter and sometimes farther away. As it moves along this orbit, the moon is continuously stretched and squeezed by Jupiter's gravity. Scientists call this process tidal heating. It's actually similar to how Earth's moon pulls on our oceans and creates tides. But on Io, the effect is dramatically stronger. On Earth, ocean tides usually change the sea level by about half a meter in the open ocean. On Io, Jupiter's gravity can cause the moon's solid surface to rise and fall by as much as 100 meters. Imagine the entire ground lifting up and down like a giant breathing object. This constant flexing generates enormous amounts of internal heat inside Io. That heat melts rock deep beneath the surface, creating underground reservoirs of magma. Eventually, the pressure builds up, and the moon erupts. Unlike volcanoes on Earth, however, Io's volcanoes don't usually form large mountains. That's because Io does not have tectonic plates like Earth. Instead, the surface cracks open due to the continuous stretching caused by Jupiter's gravity. Through these cracks, molten lava bursts out violently. Some eruptions throw lava dozens of kilometers into the air, while huge clouds of sulfur gas rise hundreds of kilometers above the surface. This sulfur is also responsible for Io's incredible colors. As the gas cools and falls back to the surface, it forms layers of colorful materials. Yellow regions are created by crystallized sulfur. White and blue areas contain frozen sulfur dioxide. Green regions are formed through chemical reactions with Jupiter's powerful radiation environment. And deep red patches often mark areas of recent volcanic activity. Instead of building mountains like on Earth, many eruptions on Io create enormous lava lakes. One of the largest of these lakes is called Loki Patera, stretching nearly 200 kilometers across. At its center sits an island of solid rock surrounded by a vast, constantly churning sea of molten lava. Thanks to recent observations from NASA's Juno spacecraft, scientists have been able to see Io in greater detail than ever before. Juno arrived at Jupiter in 2016, originally on a mission to study the planet's atmosphere. But after completing its primary objectives, the spacecraft was redirected to observe the Galilean moons. During close flybys in 2023 and 2024, Juno passed within roughly 500 kilometers of Io's surface. What it captured was extraordinary, towering mountains, giant lava lakes, and landscapes unlike anything found anywhere else in the solar system. Some mountains on Io reach heights of 18 kilometers, nearly twice the height of Mount Everest. Yet strangely, these mountains don't form long ranges like those on Earth. Instead, they stand alone, isolated peaks rising suddenly from the surface. Scientists believe these mountains may form when large sections of Io's crust collapse due to volcanic activity, forcing nearby rock upward. The result is a world that is constantly changing, a surface that rises, falls, erupts, and reshapes itself over millions of years. Unfortunately, we may not see many new close-up images of Io for a while. Future missions like Europa Clipper and the European Space Agency's JUIC mission will focus mainly on other moons, especially Europa and Ganymede, in the search for signs of alien life. For now, Io remains a mysterious volcanic world, one that continues to surprise scientists every time we look at it. A place where fire and ice exist side by side in the dark depths of space.